Hey guys, it's Michael with Breaking Concepts, and today we're going to take a look at this application differentiation question. So yeah, feel free to pause this video and try it out yourself. Hide myself as well, so you guys can, take a screenshot or whatever. So all right, so assuming you've give this question a shot, and so let's dive right into it. We're gonna make a lot more videos like this. Basically, it is a more challenging questions. For example, this one is a differentiation question, application of differentiation, integration in the future, right? So when I first started doing these, I found out that there's a big jump between high school calculus and university level. So I'm gonna make a lot of videos like these, specifically questions wise, but they're definitely more advanced, more challenging questions. So sometimes, even though if you've seen the explanation from textbook, you might still not really get it, or it doesn't really click with you. So anyways, so today we're going to do this question about aquatic birds. I've seen this before, right? The bird goes under the water to forage instead of just flying. It's actually pretty cool. And you see there's a photo here. The bird went down to forage. Okay, so without further ado, let's try this question. So first of all, we have aquatic birds. So let's go through this question together. We have, aquatic birds, they forage underwater and periodically return to the surface to replenish their oxygen stores. Okay, so well, that makes sense, right? They have to come back to breathe, right? They replenish to replenish their oxygen. Oxygen store increase with the amount of time spent, but in a diminishing way. So I guess it's going to be something like this, right? Our oxygen, right, in our lungs is going to go like this, and it kind of plateaus, and this is the maximum oxygen that we can use. Okay, so T is the amount of time spent in service. We're supposed to have the round trip of travel to and from underwater foraging area is T, and oxygen is depleted at a constant rate of R milliliters per second while the bird is underwater. Okay. And furthermore, suppose T seconds R is important. Furthermore, suppose that the bird forages until it has just enough oxygen to return to the surface. Okay, cool. So before we even go and look at A and B, I want to kind of understand, with you guys, kind of what this question is talking about. So we have a bird, right? I'm gonna forgive me for drawing so badly, but basically we have a bird here. Okay, so what it will do is it will go down, forage, right? Look for fish, eat them, right, and come back. So this is what's going on here, right? So what we've given is that, we have the amount of time spent on the surface. We have T seconds here. So the bird will actually breathe in the oxygen, store it. So OT is the function for that. It stands for the milliliters of oxygen. And the entire round trip, right, I think it's mentioned here, T seconds. To and from, okay, so the entire travel time is going to be T seconds, okay? And we know that R is the constant rate of oxygen depletion, right? So the entire journey, you can kind of envision that, let me just put it here, you will have like R milliliters per second of oxygen being lost, throughout underwater. Same for foraging. So cool. And actually, one of the most important sentence in the entire question is this one. Furthermore, suppose the bird forages until it has just enough oxygen to return to the surface. Well, this sentence basically stands for that how much you breathe in, the amount of oxygen that you've taken in for the entire process is going to be totally equals to the entire trip and the foraging time. Okay, that's basically what the sentence is talking about. Suppose the bird forages until it has just enough oxygen to come back. Okay, basically it will spend a lot of time here, and then and then making sure it also have enough oxygen to come back. Okay, so basically we can imagine this one is equals to this one plus this one. Okay, this is number one. And so writing on that, we know that our OT is going to be equals to our travel and plus our forage. And OT basically stands for the amount of oxygen in milliliters, right? Is the amount of time spent on surface, oxygen store. Okay, OT is our oxygen store, which is basically, right, the amount of oxygen that the bird has when it's on surface, which is going to be totally equals to the travel and forage. So what does travel means here? Well, travel, we want to know what is a milliliters for travel, right? What is a milliliter used for forage as well? Well, to find this one, actually, it's right here. So we know that our travel are seconds, right? We have seconds, our t seconds. If we times our r, sorry, I'm gonna get rid of this one. Get rid of this one. If we have r milliliters per seconds, then we can see that this one kind of just cross over. And so we're left with TR milliliters. And what TR milliliter stands for is the amount of oxygen that's used during our travel, right? To and from. So the total round trip oxygen. So we know we can use a different pen for this one. We can use TR, right? It's going to be OT equals to TR. TR is the, right, milliliters of O2 for travel. And we also have forage. And we're going to come back to this in a bit and explain it a little bit more, okay? So we have this from our question, we understand we have a formula like this. And so let's look at question A. Let me just remove all of those. Okay, so A, if the fraction of a single dive cycle that the bird spends foraging, find Q as a function of surface time T. Okay, so let's look at this one first. This one, just by looking at this one, is going to be a little bit confusing. So we want to look at what does Q means, right? It's a fraction of a single dive cycle. Now, what does that mean? So look at here. Our single dive cycle, well, number one, we have our travel, right? And number two, we have our foraging. But if you look at the question correctly, it says that, you know, the bird forage underwater, and then periodically, it returned to the surface, okay? So a cycle also actually to replenish their oxygen. So a cycle actually includes, you know, returning to a surface. So the entire cycle is 1, 2, and 3, okay? All right, so what that means is our total cycle is gonna be our, number one, on service, number two is our travel, and number three is our foraging, okay? And Q is to find a fraction of a single dive cycle in which that the bird is foraging. So Q is, we're saying that is foraging over the entire total, right? And then we can do this again by saying, okay, forage is going to be over to our service plus our travel plus our foraging, okay? Travel, service, whatever. Okay, this is Q. So that's the entire fraction here. But to really display this, okay, number one, we have a hint here. It's a function of a surface time T. Surface time T. Okay? So we know that, okay, the surface here, we have to write T instead because it's time. And so the entire thing, the entire fraction, we can actually also use time as a fraction because we want to know what is the portion, the fraction of time that the bird spends on foraging. So we can actually give it a variable. And I use a variable called f. Okay, let f be the time spent on foraging. Okay, so we know that. So we can have f here. So f. So we also have f here. So in addition, we need to know what is the time for traveling. Well, the time for traveling is actually right here, right? It's given. So it's t. So we know that t is going to be here. So the entire equation for QT is just going to be our F over our T, our small t plus our big T plus our F again. So now we're not even halfway to completion. And so first of all, we have F here. F doesn't mean anything if we don't define it, right? So we have to find the value of F. And the way we can do this is actually going back to here. So we know that OT is equal to our TR, right? Plus our forage. Now the forage here basically stands for the oxygen required for foraging. So how do we know? Well, we have F. F is the time, it's the second spent on foraging. So remember, during underwater, our constant R is the depletion, right? So we have to times our R, which is the milliliters per second. Again, seconds cancel each other. So we have F times R milliliters. And what this stands for is the amount of oxygen that have spent during foraging. So now we have an equation that looks like this. OT equals to T times R plus our F times R. Okay? So I hope that makes sense. And so we can see that, okay, this function is actually a representative as a function of T. So all we gotta do is do some manipulation. And then we can get, okay, so our OT minus our TR, and then equals to our FR. And then to find F, all we gotta do is just move R to the other side. So OT minus T times R over R. So this is our formula for F. And all we gotta do is just move this back to here. Okay, so I'm gonna use a different pen just for clarification. So I have QT. Ooh, blue looks good. It's a more soothing color. OT minus TR divided by R, that's F. And then we have T plus OT minus TR divided by R. Okay, so we got this formula. And obviously we're not done. We can actually just cancel the R, but before we can do that, we have to make sure these becomes over R as well. And to make these becomes over R, we can do this. OT minus TR over R, and then we have T small tr and a big capital TR divided by our OT minus TR divided by our R. So after having this one, we can start doing cancellation. We want to cancel R and R because we don't need it. And if you can see here, we have plus TR and minus TR. You cancel this one as well, okay? So we have something like this, OT minus TR over OT plus TR, okay? So we have this one. And now what is OT? OT was given, so it's 20T over 5 plus T. Okay, so we have 20T over 5 plus T minus TR, and then again 20T over 5 plus T plus TR. So now we have a fraction like this, and actually we can use the same concept and remove our denominator, 5 plus T. So 20T minus our TR times our 5 plus T is going to be directly over 20T plus our TR times 5 plus T, okay? If you don't understand why we can get this directly, because basically I multiplied this by 5 plus T and 5 plus T, okay? Now 5 plus T over 5 plus T is actually 1, okay? That's why we can do that. I do this for this one as well, and that's why we get this one. So you can try it out yourself. And yeah, let's move on. So now we just continue forward. We have 20T minus our 5 big TR, and then it is minus again, so you have minus T small t and big TR. And then you have 20T plus our 5 TR plus our T squared R. So we have this here. And now for simplicity, we can actually take out T from these two. So we have T taken out, and then so therefore we have 20 minus TR minus 5TR, big TR, and then we have 20T plus 5TR plus T squared R. So we have found that QT is equals to this one, okay? Okay, so this is the answer for A, okay? And now we're gonna go for B. So basically the QT, again, is the fraction, right? So this is answer for A, which is the fraction of a single dive cycle spent on foraging, QT. Okay, so now we can go to B. B is so simple. Basically, we have T equals to 2, and R equals to 1. And it says find the surface time T that maximize the fraction of time spent on foraging. And the way we can kind of do this is using optimization. So QT basically is, the time spent on foraging over the total function. So if we maximize this function, we can find the time that gives the output where Q has the highest amount of time spent on foraging. So most of the oxygen is being used on foraging instead of like traveling, whatever is spending on service. So this is basically what optimization means. We want to maximize the fraction of the bird spending on foraging, right? We want to invest more time on doing something that's actually productive. And so given T equals to 2, R equals to 1, so we have T equals to 2 and R equals to 1. Okay, T is seconds, R is milliliters per second. QT equals to our T And then 20 minus TR basically is 2. And then minus 5. And then minus 5 times TR. 5 times TR is actually 2. Okay, so then you have 20T plus 5TR. 5TR, 5 times 1. So it's 5T. And then you have T squared times R is 1, right? So it's T squared. So now we have 18T minus 10. And then you have 20 plus 5 is 25T. And then plus T squared. Okay, so this is our QT function. So here we can start doing the differentiation. So now we can do the quotient rule. And the quotient rule, basically we have QT, Q prime T, and then divided by 20T squared plus 25, and then T, and then squared. And then we have T squared plus 25T times our 18 minus our 18T minus 10. Okay, and then you want to do 2T and then plus 25. Okay, so we have this one. Forward, so we have 18T squared plus 450T minus our entire thing. So we have 18 first. 18T times 2 is 36T. And then you want to plus 450T, and then negative 20T, and then plus minus 250. Okay, so this one over T squared plus 25T squared. We do this is 18T squared plus 450T, and now we gotta flip everything from negative to positive. Negative 36T, T squared, oh, that should be T squared, no? Yeah, sorry, my bad. T squared, sorry about that. And then minus 450T, and then you have plus 20T plus 250. So all this is going to be over T squared plus 25T over T squared. And then, okay, so plus 450T minus 450T. These ones is going to be negative 18T squared. And then you have plus 20T and then plus 250 divided by our T squared plus 25T. Oh, and then squared. So all we gotta do right now is to finish this up. So we can do this by taking our negative 2 out. So negative 2 is gonna take it out. We're gonna have our 9T squared, negative 10T, and then with negative 125. And then divided by T squared plus 25T squared. So this is what we get for our Q prime T. Now we can finally go to optimization. So optimization, basically, we're trying to ask for, or what happens when our Q prime T is 0. So we have a bunch of stuff here, but basically all we got to do is just focus on this one, because only this one becomes 0, then the entire thing becomes 0. If this is 0, the entire thing is going to go to infinity, which doesn't make sense, right? So all we got to do is take 9T squared minus 10T minus 125 equals 0. So this is a quadratic equation, right? And we can basically find T. And actually, so I'm going to use ChatGPT or Gemini to find this for me. So from our Gemini, we actually got the result of these two. And obviously, there's no negative seconds, so we're going to reject this one, okay? So we found out that the answer is going to be T equals to 4.324. So after a lot, so what does T equals to 4.324 means? So basically our value is saying that by spending that amount of time on the surface, we're actually maximizing the fraction of time that we spend on foraging. So again, going back here, okay, because we're spending 4.324 seconds on the surface allows us to maximize our time on foraging, given if T is equals to 2 and R is equals to 1 milliliters per seconds here, okay? So this is the answer. And I know that's a long kind of process, and I hope that makes sense to you. So yeah, there's going to be a lot more videos like this coming up. Thank you.